will be a loss in.
Welcome, sir.
So, good morning to everybody. So, I'll just go on to the next slide. Is it moving or not moving? Okay.
Moving, sir.
So, as you know that as Praveen Kumar has told about sustainability and other thing, and we know that concrete is very largely used material in the world. And if you see the statistics, it is per capita consumption is around 2.5 tons per capita consumption of concrete, and it is huge. And in that, if you take it as a aggregate as is it only, then it will be around 8 to 12 billion tons, and that is a huge quantity. And as a sustainability defined as the using the resources in the manner that enable people to meet their current need while allowing the future generation to meet their needs. So we cannot consume all the aggregates at present, and then we can leave without natural aggregates to the future generation. So we may have to go for the alternate materials to replace the natural coarse aggregate. And in that cases, this recycled concrete aggregate from the construction and demolition waste is one of the component to study. So if you see the construction and demolition waste, it contains soil, bricks, stones, concrete, metals, bitumen, wood, and other thing. So if you have to segregate the thing, so if you take out only the concrete and then you make it as a concrete, then you can call it as a recycle concrete aggregate (RCA). And if it contains all the brick, stones, concrete, some wood and other tiles and other thing also into that, then you can call it as a RA. So this definition you can just remember, because IS 383 also defines the RCA and RA in a different way. So RCA is only the concrete which is broken and made into the aggregates, whereas RA, recycle aggregate, will contain concrete, bricks, uh, and other materials from the construction and demolition waste also. So using this recycle aggregate concrete, there are a lot of studies have been conducted, and it can be used as a material in a concrete. So that's why it can reduce the impact on landfilling and decrease the energy consumption also in the future. So, and government also is taking care of using this material. So like a central pollution board also has estimated that this waste generated around 48 million tons per annum, and which 25% are from the construction industry, and the major construction waste generation is from demolition and building waste. Because we are generation to generation, we are changing the requirement, and then we are going from old house to new house, single house to the multi-dwelling house and all that thing. So there is a lot of demolition is taking place in the urban area, and that's why that generation of this waste is increasing. And there are separate rule is also provided by Government of India, that construction and demolition waste management rule, in which they says that more than 20 ton or more in one day, or 300 ton per project in a month can be classified as a there is some specific requirement is there, and in that they cannot dump into the landfill directly, and they have to segregate the concrete, soil, steel, wood and other things, and they have to use it for their purpose, or they can be recycled. So this is the government rule is there in 2016. So that way also this construction and demolition waste also we have to use it in our construction activity. So try to use this material as a material for that construction only. So wherever we are demolishing the thing, there itself it has to be used in a proper way. So if you take this IS 383 2016 code also, it says a recycle concrete aggregate and recycle aggregate. So these two definition is there. So concrete aggregate will contain only the reinforced concrete portion only. You are breaking it to pieces, and then we are making it aggregate. Whereas recycle aggregate contains all form of material. So and their usage in plain concrete is up to 25% replacement, and in reinforced concrete it suggests up to only M25 grade and 20% replacement, whereas in lean concrete less than 15% M15 grade concrete you can use 100% this thing. So these are the coarse aggregate, and same way fine aggregate also can be used in construction. So that's way IS our code also recommends to use this material as a construction material. So, but there is some restriction because of properties, and it has a varied properties, mechanical and durability. So they are, that's why we are restricting. But research is going on to use it 100%. And some of the results what I'll present is up to 50% and 100% replacement of natural aggregates. And other aggregates also, like steel slag aggregate and copper slag and other thing also has been recommended to use in IS 383 codal provision on aggregates. And if you see the actual action on reality also, people are using it, this aggregates. So if you see this, even in Noida recently, there is a, in 2020 there is a newspaper news that Noida they are keep putting up the factory of recycle aggregate, and their transportation and processing fees are laid per ton, and then because any demolition is taking, they have to segregate, then they have to supply to these people, and they will make the aggregate and they can resell, or you can collect it from them also. So this is a recent one. And even in earlier February 2019 also, there are 3 plants in and around Delhi near Mundra and Varai and Shastri Park. So these also are being used. So around 6,800 tons of uh, construction demolition waste is produced, and in that around 2,650 tons is been made the aggregates, and they are recycling it. So that way they, in Delhi and around area also it is going on, and in future plan also they have shown, and so in that only that Noida plant also is coming. So as government also is taking initiative to use this aggregates in our construction activities. And even in Ramagundam plant, also there is a, in Andhra Pradesh also they are setting up the thing, and at Mudra municipality administration of this thing at Hyderabad also they are using it. So they have put a plant in recently, and this has come in November 2020 news item. So that way people are, and government and people also are using this material. So some of the studies what we have done, and this thing I'll be just presenting. So normally this aggregate concrete will be recycled concrete aggregate will be having a higher water absorption and lower compressive strength and higher uh, chloride permeability compared to natural aggregates, and it has fracture energy and fracture properties also are different because of the adhere motors and this thing. So normally these aggregates are contain old aggregates and old mortar, and then when we are using it into the concrete, so there will be a different uh, heterogeneous phases will be covered, like there will be a old mortar, new mortar, old interface zones, and between the mortar and concrete aggregate and other things. So this has got number of layers. In that whichever is a weak, so that has a problem in creating the failure in the things, and it has got the durability related problems. So this also strength wise, when you are using it replacing at equal level, there will be a problem in the mechanical and durability properties, and how it has to be overcome we will see in our my presentation. So from worldwide research and other thing, they have reported that this RCA concrete will be having a higher water absorption, lower strength, and mechanical property. If you take it as tensile strength and other thing also will be lower. So that has to be accounted properly. But why it is happening is because of the adhered mortar to the aggregates in the recycled concrete aggregates. So this is a normal process of demolition in this thing. The building will be using the hammer, jackhammer, it will be broken. So there will be aggregate, this bricks will be there, aggregates will be there, and wooden plank and all that thing will be there. So you have to separate out each individual component. So if you separate out concrete and remove the reinforcing bar, and then if you take it and make the aggregates from this, then we can call it as a RCA, recycled concrete aggregate. And if it contains all bricks and other tiles and other things also into that, then you can call it a recycle aggregate. And this wood and all the thing you can recycled because these are all going as a replacement easily. So people take away all wood, steel and all that thing. So any demolition site, if you see that there will be leftover is only concrete and bricks and other thing will be there, and that has been taken to the land filling side, and then they will be having disposing this thing. Sometimes they will leave it in that site itself if they are not constructing at the site the new construction. But what this government rule says that if you are producing more than 20 ton per day and or 300 tons per month at a site, a demolition site, then you have to segregate, you have to clear it, and you can try to use it in their construction itself at site. So that is the stringent policies they have taken, government has taken. So now if you have separated the aggregates and other things, then the next big boulders have to be made it smaller size, and then we have to crush it, and then we can sieve it, and then we can use the uh, aggregates in the this thing. So there are crushing is required. So that depends on type of crushers. So like a hammer, we can make it bigger chunk to the smaller chunk, and then crushing the crusher, we can use the thing. In crusher also there are different types, like a flat jaw crusher, V-shaped jaws, or a cone type crusher, and that has an impact on the aggregate size and properties of aggregates, like a flakiness and mortar content and all other things will be having a different. So definitely this crusher will play important role in the classification of the aggregates. So if you see this thing property wise, because it has got adhered mortar, so you may find that there is a large amount of 4.75 and above will be there compared to natural aggregates. So these are all natural aggregate, and these are the RCA. So this RCA, you can see that there will be higher percentage because size of the aggregate is going to little increase, because originally it may be having 4.75 to 20 aggregate, but when it is attached to mortar, then that size is going to increase, and it has attached mortar is there, which will be causing some damages, like it change its properties. So they to study the different jaws crusher, this thing also in our laboratory we had got flat jaw and the V groove jaws. So when we put the bigger chunk and we crushed it, this V jaw, you know that better, that loose particles mortar can be removed very easily, and it has got low mortar content in the aggregates. So that is reflected in the various properties of the aggregates. Like a natural aggregate, it has got bulk density of around 1650 to 1700, whereas RCA in flat jaw, it will be only 13 to 1400, and with V groove, it will be little higher value will be there, because the mortar portion is little removed, higher content. So that way there will be bulk density will be different. Specific gravity also will be reduced drastically, and crushing value will increase because the mortar content is there. So when we are testing for crushing value, the finer particles will be higher. So this RCA will be having the higher crushing value, and then water absorption also will be higher compared to the natural aggregate. So natural aggregate water absorption is around 0.5 to 0.75, whereas RCA will be having around 6% or 5 to 6%, and with V groove, because most of the mortar is been removed, so that's why water absorption is reduced compared to flat aggregates, but still it is higher than the natural aggregate. So this is the property which we have to account in our mixed design, and then we have to follow proper mixed design procedure to arrive at this thing. So there is a no direct rule that you can just replace the material 25%, 50% or 100% as it is, because this bulk density and specific gravity and other things will matter in the proportioning of the mix of concrete mix. So that has to be accounted properly. So you have to take care of aggregate recycle aggregate property into the mix design, and it varies from the raw material processing and other thing. That's why standardizing of this RCA in practice is little difficult, and that's why its use has been restricted in IS code also. Once we understand the properties and other thing, we can at least make some standardization, then only we can go for higher percentage of concrete aggregate into our concretes. So now, what is a method to see how much mortar is attached and how to remove it and other thing? So one is acid pre-soaking test is there. In that we have to take it 2 molar sulfuric acid, and we have to soak the aggregate in for 6 days. Then you can remove totally the sand from the mortar from the recycle aggregate. So you can get a fresh aggregate only. But this will be having a costliest thing. So it is only taken as a laboratory test to identify how much mortar is adhered to your recycle aggregate. To evaluate that percentage, only you can use it and how compare with the different methods. So this you can take it as a laboratory test to find the what is a mortar adhere to the your aggregates. So if it is a low strength concrete, then you will be having a higher mortar content, and if it is a high strength concrete, you will be having a lesser mortar content, because if you take a 1 to 4 concrete, it has got 1 and 6 is the mortar, 6 is to uh, aggregate content, and the mortar is less. Whereas in high strength concrete, mortar content will be higher because aggregate ratio will be different. So that way, the strength of the concrete also matters in this to evaluate the mortar adhere to the aggregates. So what is the other methods? Other methods are heating and rubbing techniques what we have adopted in our laboratory. So mainly what we do is we will heat the aggregate to up to 250 degree centigrade for 4 hours, and immediately we will soak into water. So there is a difference in the temperature of surface temperature of aggregate and mortar. So there will be some delamination, and once you squeeze it into water, their separation will take. Then if you rub it in by some mechanical this means, we have used the pan mixer for rubbing the things, and then we have separated the aggregates. So there definitely there is involved some energy, additional energy is required to separate the thing. You can use it as it is a rubbing technique, but the mortar removal will be less content. So people are using only rubbing technique also, and then heating and rubbing technique also. And heating also we have tried with different temperature and different hours, but finally we have settled down to 250 degree for 4 hours heating. If you are using lesser this thing, you may have to go for higher hours of heating, but this can be used at wherever the extra energy is available or hot gases are coming out from the some of the factories and manufacturing units. So that heat we can take it as a supplementary source for this, and that can be used for heating the aggregates and then separating the mortars, because this mortar attached to the aggregate only causing the problem of the reduced strength and higher water absorption and chloride permeabilities. So this is the thing. People are using microwave techniques and other technique also to remove the mortar from the aggregates. Here only we have to just see the how to remove the mortar from the aggregate. So we there, because there will be a temperature gradient and other thing will be there between mortar and aggregate. So you have to adopt some technique, mechanical way or some heating or anything. We have to remove the thing. Acid soaking is only we can take it as a uh, 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 laboratory test to find out what is the original mortar content and how much by this method, what is the maximum percentage we can remove it. So these also just you see the properties, even natural aggregate will be having the thing, RCA will be there. By treating the or removing some of the mortar, you can improve the or specific gravity, water absorption also is reduced. Your bulk density also will be this thing, and your crushing strength also can be improved depending on the how much mortar you are removing. So this variation in this property you have to take it care in the mixed designs. Otherwise it will be having a problem of properties. So to have a different, we have gone in different phases. So first phase what we went is just we have a natural aggregate and then we have replaced with 50% with RCA, recycle concrete aggregate and 100% concrete aggregates. So we have used around 0.47 water cement ratio and this aggregate. See, because even if you see the natural aggregate is around 1030 kg per meter cube, but whereas recycle aggregate when we are replacing it 100% is only 921. Because this is because its specific gravity is different, lower. So it has got because volume adjustment has to be done. So for same volume, so whatever volume of natural aggregate was there, so same volume we are taking, so its weight will be reduced. If you are not doing this correction, then you will be having a much more problem in your mix and yielding of the total volume of the concrete will be having a difference will be there. So if you are making it with 1030 as it is, if you are replacing this 100%, then your volume of concrete is more and you will find that there will be extra material left over. So that yielding problem will be there because cement and sand we are not changing. So that volume will remain same. So when we are changing the volume of natural aggregate to recycle concrete aggregate, then you have to be take that volume adjustment and then we have to use it. So this is the first phase we have taken only the 50% replacement and 100% replacement. And in second phase, what we did is we that heating and rubbing technique, the treatment we have adopted, and that we have done it. So that you can see that when it is 100% 1030, whereas recycle aggregate 100 is 921, whereas treated 100% is 974 because its specific gravity is changed now because it was earlier it was very less 2.4 and now it was around 2.6 whereas original was 2.77. So that's why that difference is coming and that way we have to account for the in the volume adjustment. Then when we studied the thing, even we have seen there some improvement in strength and durability properties, water absorption and fluoride. So then still, but we have not got up to the natural aggregate. So then we went to third phase where we have used around 10% fly ash and the 5% silica bloom as a replacement. But we didn't replace the cement. We replaced that quantity by the aggregates only. So that way we have done in third phase. Cement content we have kept same, but 5% and 10% cement weight we have replaced with the aggregates. So if you see the strength from first phase and second phase and third phase, so first phase we have replaced only the recycled concrete aggregates. So from 44 MPa concrete it has come down to 37.8 and split tension also has come down and water absorption also has increased and then RCPT charge also increased. So this is a water absorption of the concrete. Don't confuse with the aggregate water absorption. Aggregate water absorption will be 0.5 to 0.7, but concrete will be having a 2.5 to 4 percent absorption will be there depending on its strength and other things, porosity and other things. But still it has got the higher values. So when we are heating and rubbing technique we have adopted, so treated aggregates have been used. There is a reduction in water absorption, there is improvement in chloride permeability test also, and there is improvement in the strength also. But it's not reaching up to the natural aggregate concrete. So when we gone into third phase, that is 5% silica plume and 10% fly ash, which we have added to the concrete, that is a replacement of aggregate. You can see there is a drastic increase in the strength also, and the properties of improvement in uh, chloride permeability, because fly ash concrete will be having a better chloride permeability, and in silica plume concrete also you can find it. Water absorption is also little higher than the original this thing, but it is nearer to, you can take it as a closer value. But there is a definite improvement in strength and chloride permeability. And here, because we are adding in addition to cement, so there will be, as we know that whenever extra mineral admixtures is added, there is an improvement in strength. So even if you have added in the natural aggregate mix also this 5% and 10% mineral admixture, definitely that might have gone more value. So here this improvement is not because of the aggregate replacement only, but it is because of the cement replacement material also has been improved. So both way we can have the thing. So in next phase we have gone, because silica plume is very high cost and other thing, and fly ash also volume is high. So we tried with the biomass silica MBS, because these are come from the rice gas burning, control burning rice gas. So we have procured that rice gas ash, and that has got very high silica content, reactive silica, and it has got very high this thing, but the cost compared to silica plume, it is very, very low compared to silica plume. So we wanted to try this MBS material into the as a mineral admixture, and because it will come between fly ash and the silica plume. So we have tried with different properties. First, its specific gravity we try to replace with the cement, because it has very low specific gravity. It is specific gravity is only 2.19. So when we are replacing with the cement, we have to be very careful in taking into account, because when we are replacing with 4% biomass silica, the specific gravity will come down of the cement paste cement, it will come down to 3.1, and if you are going higher value like a 12%, then it will come down to around 2.95. So there is a difference, a huge difference will be there. So, and if you are not accounting as in a volume adjustment, then there will be definitely problem in the concrete mixes. So the addition of this MBS into cement, so cement paste only we have studied initially, specific gravity, standard consistency, and setting time there won't be a problem, because we are replacing less percentage only, around 10%. So there won't be a much difference in initial and final setting time. It is under the whatever standard specified, it will be there. But definitely there will be a change in the specific gravity, standard consistency also will be improved, and its flowability also will be problem. So it demands more water. Free water has to be added, additional water for same workability. Otherwise, you may say there is a loss in workability and other thing, because of the standard consistency is increased. So additional amount of water will be required for your workability purpose. So whenever this type of material, when we are using it into this thing, you should take care about all these parameters. Otherwise, you may say that by adding a mineral mixer, I am losing my workability and other. So that loss of workability may be due to increase in the standard consistency limit or decreasing the specific gravity, so volume of the total volume is increased. So once volume is increased, your initial water, whatever you have provided, that may not be sufficient, and that may lead to the uh, flow problem and workability problem. So based on these studies, we chosen the 8% as optimum content. So even our compressive strength also is been improved, and at different ages. So also this thing is there. So based on this study, we have taken, say, we concluded that 8% of microbial mycelica may be adopted in the concrete mixes to improve the properties. Because cost, when we are going for silica plume, we should not go more than 4 to 6% because of the high cost and high volume of silica plume required in that thing. Whereas in fly ash, you can go optimum is around 25%, and you can go up to 35% replacement. Whereas in slag, you can go up to 65%. Whereas in MBS, microbiome silica, you can go up to around 8 to 12%, but we have taken it as a 8%. But based on the initial studies, how it will react. So that depends on the initial your cement also. So if we are taking a high grade cement, then it will be having a different these things, percentage and other thing. Its effect on the consistency and the other properties will be different. So you may have to try out when you change the source of your OPC cement also. So when we are using this biomass silica, we have tried, because earlier we have seen that when we are keeping the cement content same, there is a drastic change in the property of mechanical property of mineral admixtures concrete, which is higher. So we try to replace now with the cement itself, and we are not changing the recycle aggregate quantity in this thing. So just we have taken as 8% of replacement of cement, which is very small quantity. Even for different water cement ratio, you have tried 0.55, zero point 0.5, and 0.45. It's only 25 to 30 kg is added. But there will be some change in the volume will be there, because its specific gravity of cementitious material is changed. So you may have to change the or adjust the quantity, and that you can account it in your total aggregate quantity itself. You can account for that volume adjustment. So that's why there is a difference in the weights in the things, and there is a difference in uh, material also. So this sand volume, as we know, when there is a change in water cement ratios, there will be definitely change in the aggregate total aggregate ratios. So in that only this sand ratio also is being changed. So this has to be accounted based on the volume adjustment of the things. So we have tried with 50 per this heating and rubbing 100%, and this with microbial silica. So with three different water cement ratios. So you can see that almost now we are getting, when we are replacing with heating and rubbing aggregate, there will be reduction in strength, but by 8% microbiome silica, it can be got the similar same strength. But there will be and also will be, but there will be and RCPT value also nearer to this thing. And when we go for lower water cementitious ratio, you may want in the RCPT test. Materials you are using, it has to be adapted properly in the mix design, and then you can try it. Definitely we know that when water cement ratio is high, the durability values will be higher only. So when this reduction in the 0.45 is may not be due to only with microbiome silica, it is due to reduction in water cement ratio, cementitious ratio also. So that way we can take the things. So what my emphasis is there, whenever you are using mineral admixtures into the concrete mix, you should properly account its specific gravity, bulk density of the that aggregates and other things. So that has to be taken care of to have a better mix and better properties in these things. But from these studies, heating and rubbing method will improve the aggregate property and its mechanical and durability properties also improved, but not to the extent of natural aggregate. So we have to go for additional mineral admixtures like a fly ash, silica album or microbiome silica, or even you can try with even slag also, where you can go little higher percentage and other things to reduce the cementitious content, cement content also. So then we now know that there is a improvement and then there is a decrease in the strength when you as it is you are using it. Why it has been happening? So this recycle concrete aggregate, old mortar, new mortar, old inter transition zone and the new transition zones. So there are so many transition zones. In earlier case, natural aggregate only, we only natural aggregate and the mortar and the transition was there. But now this thing is additional two zones are going to come between old mortar and new mortar also, and with the new mortar and the aggregate also. So whichever is a weak plane, in that crack will start and propagation will go and the failure will happen. So in low strength concrete up to 150 MPa concrete, you may see the aggregate, there won't be a fracture. All fracture surface will be between the aggregates. That way, up to 50 MPa concrete, mortar only is a crack initiation portion, the old mortar and new mortar. So if it is a good transition zone, you can have little higher tensile strength and other thing, but otherwise you will be a lower. But how to find out? So that's why people are studying with the fracture parameters of these concretes. Then we also have studied. So according to Raylam standard and other things, there are some fracture energies and fracture toughness can be evaluated, so that I'm not going into equations and other things. You can just refer to some of the standard on fracture mechanics and you can just study in details. What just I will say that from the mixed design point of view and from properties point of view, we can evaluate this thing and we can see that there is a change in the things. So this fracture toughness and other thing also you can calculate based on this thing. For that we have to follow some of the procedure or standards, like Raylam Committee T87 gives that you have to follow this notch depth to beam depth ratio of 0.2 and span to depth ratio around 4, so that you can use that equations and you can calculate it. So different specimen sizes also you can use it, 50 by 50 by 200 or 50 by 80 by 320. So like that you can use a different size of the thing and then you can evaluate the fracture energy and fracture toughness of the concrete. So these are normal aggregate. Whatever is the procedure is there, same procedure we are evaluating, and we want to know why there is a decrease in the fracture energy or fracture toughness when we are using the recycle aggregate. So that is the main purpose of study of this study. So we have made the same concrete using the replacement treated and with the fly ash and silica bloom concrete. So then we can just compressive strength also as earlier whatever was there, and similar thing only we also got it, and then reduction is there in 15% for RCA, and heating rubbing will improve, and the fly ash and silica bloom will be much higher than the things natural aggregate control concrete. But when we are studying this low deflection plot of that beams, and these curves we are obtained from the displacement control test, not as a load control test. You cannot get this type of curve. Only in displacement control with high precision, only you can get this type of plot for plain concrete. So there is as a compressive strength and tensile strength is different, that will reflect in this plot. But post peak will give you some idea about interface, how that interface is working. So to know this thing, we have to find out the fracture, crack opening, displacement, and other things. So that I will come in later. So that will reflect the why the initiation is. See the slope, it will be very flat in a recycle aggregate. Means fracture is taking place immediately and there is a drop in the load carrying capacity. But that can be improved slightly, but not to the larger extent. So this fracture energy and toughness, so you can see that control is having around 1, and that depends on the size of the specimen also, because these are size specific values. But it will be having in range. If you see, there will be drastic reduction when you are using a recycle concrete aggregates in the things. So definitely there is a reduction in tensile strength and flexural strength and other things, and that may lead to reduction in compressive strength also. So this is the cause in reduction of mechanical property. Why it has been happening? It is because of this lower fracture toughness and the fracture energies. But you can improve using fly ash and other thing, but we are not able to reach to the natural aggregate things, because still there are some old mortar is attached to the aggregate, and which causes the fracture of early fracture into the concretes. So these are low fracture and weak interface between aggregate and old cement paste, and that energy needed to create new fracture surface is reduced, and that's why that is reflected in the lower fracture energies. So now one more study, same data, whatever data or that low deformation plot I have shown it. From that itself, we can evaluate the stress crack opening relationship, and that will explain little more clearly that why there is a reduction in the fracture energy and other things. So stress crack opening relationship we can make, we can evaluate from fracture mechanics parameter and that low deformation plot. There are some equations are there, and this crack hinge model which was given by Kaiser in 1993, we can adopt that thing, and this is nothing but iterative procedures, and people are using it this extensively to evaluate the stress crack width opening parameters. So it is nothing but we assume the constitutive relation in this way up to pre crack. Before cracking, we assume like a straight line as uh, E value and tension. So up to FT value, it will go in this way. But once it reaches FT, there will be a sudden drop in, and because crack is start opening up. So that's why we say that strength versus crack opening, or stress versus crack opening. To normalize this stress, we take it as sigma by ft, and it is taken as 1, or you can take it as a sigma x also. So but it is instead of this 1, it will be ft, whatever your tensile strength is there, direct tension tensile strength. So that only we have to take it that. So this way there will two slopes. One will be because of micro cracking and crack opening, and other one is will be because of the frictional resistance between aggregates and the mortars. So there will be some interface friction will be there. So that's why once crack initiate, it will be suddenly drop will be there, but once after some crack opening, there will be some frictional resistance will be there, aggregate interlocking and other thing will be there. That's why that will be slowly opening things. That's why W1 and W2 crack width will be in this majority will be on aggregate interlocking, interface friction will be creating taking place, energy absorption. So this way this energy can take. So this we assume in initial stages, the parameter, this A1, A2, A and W1 and W2, B1 this thing. So based on this assumption, we will try to model the once again and optimize this parameter to get the same load deformation plot. So this based on these values A1, A2 and B2, we try to fix the this whatever load deformation plot we have got experimentally. Then model initially we assume this parameter A1, A2 and B2 and then try to optimize and we try to get the plot model plot same to this. So which value of this A1, A2 and B2 gives closer to the experimental, then that parameter constitutive relationship, we can say that it is for that mix or that concrete. And that will vary from the type of concrete this thing and the type of size also, but not much this thing. So if you see NAC and recycled concrete aggregate and heating and rubbing and uh, fly ash and silica film concrete, we have tried and plotted the things and then we arrived at these are the parameter. Definitely FT is varying and then this parameter also changes. So when we plot in constitutive way, so you can see here, this is initial slope and this is the thing. So this is W1 and this is W2. So W1 is around 0.04 and W2 will be around 0.15. Whereas in case of recycle aggregate, you can see that it will be around 0.3 and 0.12. So your crack width also reduced, critical crack width. And when we are using the improvement in the heating and rubbing things, mechanical removal of motor, there will be slight improvement in the W2. And when you are using fly ash or silica film, you can see that it is similar to this. So this bilinear softening parameter, tensile strength and the fraction energy obtained from this thing. And it should be known that two major mechanisms responsible to observe the tension softening in concrete, namely microcracking and frictional aggregate interlock. So this first slope is there W1 will be for microcracking. So you can see that when we are using fly ash or silica flume on microbiome, why it is been improved? Because your W1 is improved compared to this thing. And when recycle aggregate alone is used, this W1 is reduced. That's why that microcracking is still happening in this zone interface. And that's why it is giving you this thing. So once it this is the energy in this area also is reduced and that leads to the reduction in the total fracture energy and other things also. So that way and this shows that because of micro cracking between the aggregate and the old mortar and the new mortar and aggregate surface zones, there will be frictional forces and other things. That's why the energy is lost, reduced, and that way it is affecting the your mechanical properties. By silica bloom or fly ash or mineral admixtures, you can treat the micro pores and other things, and you can improve little this micro cracking, but not completely. You cannot avoid the thing, and that way it is slight improvement is there in fracture energy and other thing because of this thing. But it definitely improves the mechanical strength. Durability property wise also, this mineral admixtures is reducing the pores and discontinue pore structures lead to improvement in the durability properties. So that way, definitely recycle aggregates are to be used in future in extensively, but it has to be taken care that this basic property of aggregates are changed. Like if you are using uh, aggregates from southern region that things, and if you are going in north, you are using sand stone aggregates, or in Western Ghat, if you are using some different, we are accounting that different aggregates have got different properties, and that we are taking into our mixed design. Same way, these recycle aggregates or any supplementary new aggregates, aggregates, you should use it in the concrete with proper properties of aggregates. You cannot replace just as it is, and it has to be taken in volume adjustment and properties and other things you have to take care. So that way we have to use these recycle aggregates, concrete and other thing in future, but with proper addition or mix proportioning things. And fly ash and mineral admixtures like a silica plume or any other mineral admixtures you can use for improvement of strength. You can, whatever loss is there because of the recycle aggregates, you can compensate by mineral admixtures. And treatment is necessary, but it will be added to the cost of the manufacturing cost. So try to balance between treating aggregate or by changing the mix proportioning, reducing by water cement ratio and other method, you can try to achieve your required strength. You can play with the mix design procedure and you can arrive at the given aggregate. But wherever you need to be use your tensile strength, flexural strength and other properties are important, you should be careful to evaluate. You cannot take it at 0.7 root FCK as the value and then you can this thing, because all mineral admixtures will give you very high strength, but similar improvement in the fracture properties will not be there. So you cannot use the same parameter, same ratios for the uh, this recycle aggregate concrete or any mineral admixture concrete also. So we can recommend that detailed studies on structural behavior also you should carry out, and that's why only IS code also restrict only up to 25% replacement, and that also up to M20 grade concrete only. But in lean concrete you can go for 100% replacement, and plain concrete also you can go up to around 25% replacements. So that way people are recommending, but use has to be increased in future with proper accounting and other thing. People are making municipal corporations and other people are also trying to put up a plant and recycle these aggregates in some of the places, but that will going to be increased in future. Even ICI also has come out with some guidelines and one special issues and other thing also. So you can study that also for further your knowledge, and then you can just investigate and try to use this material in your practice. Thank you. Any question is there, I can take up.
Yes, participants are requested
Praveen
to.
Kumar.
Yes, thank you. Participants are requested to hear their questions. Participants can unmute themselves and ask questions from the learned speaker. Any participant is encouraged to raise.
I think he has to unmute first.
Yes, I have unmuted all, means they can unmute themselves now. Rakesh Reddy ji has written in chat how to remove mortar from aggregates. So the speaker has explained it, but may consider to
No,
again.
that's what I have just shown one laboratory test and the normal thing. By rubbing each other aggregates, also you can remove the mortar. So but just put it in a pan mixture or something in dry rubbing thing, also you can remove, but the extent of mortar removal will be less. So that's why people are using heating and then squeezing in the water immediately and then rubbing, so that separation will take place. Acid soaking is only for laboratory purpose to find out what is the attached mortar. And by changing the crushing pattern by using instead of flat jaw, if you are using the V-groove jaws, or you can go for cone crusher type of things, then there will be a removal of motor will be there. So that way only we can remove the motor from the aggregates.
Any other query or questions by any participant? Dr. Deepali has written, reducing water cement ratio, can we get more strength? In chat box. Kindly refer chat.
Now kindly tell me once again.
Dr. Deepali,
Repeat.
may unmute yourself because Dr. Deepali Paresh Doshi, she has written, reducing water cement ratio, can we get more strength?
No, that's what, because this porous.
Good morning, sir. Am I audible?
Tell me.
Sir, you have considered water cement ratio up to 0.4 or 0.45. Suppose I am reducing the water cement ratio, can I get more strength, or it reduces the workability of the concrete? RCA की बात करेंगे. I am asking regarding RCA.
Workability will depend on the water content. So if you are keeping that whatever 170 liter water, you can go up to even 0.4 and 0.38.
Okay.
Okay. So because this will be Rice's rule is there, which says that water content only matters for workability up to some range.
Okay, sir.
And the cement content should not be more than 450 and it should not be less than 300.
Okay, sir.
So you can work between 0.38 to 0.55 in that range.
Okay.
But if you still want to go down, like people are going for ultra high strength concrete and other thing, 0.28, 0.32 and all that thing, then water content will be much less, and then it has to be around 140 liters, 135 liters. Then you have to go for high range water, super plasticizer and other thing to get the workability.
Okay, sir.
But you can definitely go up to 0.38 or something straight away.
Okay, okay. Thank you very much, sir.
But your binder content will be around 450 or something.
Okay, sir.
Any other query by participants? Seems no further queries. So, with this, I thank the esteemed speaker and the very high caliber Dr. Bharat Kumarji for sparing time even in the morning on the working day in SERC. So, express my gratitude from heart for sparing today's session and the research with us, sharing research with us. On behalf of AICT and my Rajasthan Technical University, I, with folded hands, thank you once again, sir. So nice of you, sir, for joining.
Thank you, Praveen Kumar.
And with this,
Thank you.
with your permission, I stop recording and.